Let us study a new topic, what is inertia. The tendency of a body to remain in the existing state is known as inertia. It may be at rest, it may be in motion, or it may be in the direction of inertia. Now, so we can say that inertia itself is of three types. First one, that is inertia at the rest. Second one, inertia during motion. Third one, inertia of direction or directional inertia. Now we will study what is inertia at the state of rest or inertia at rest. For that, I am showing you one example. Here I taken one box. It is in the open condition. On that I am keeping one card or paper I taken that I folded and kept. A plain paper it is that I folded and kept. After that I taken a coin and kept on it. Then just with high speed we have to flick on it. But we have to see that this box we have to keep on a tabletop. Then we have to flick on this paper, or if you are keeping a card or an envelope, then on that you have to click it by keeping on the table. So you can find that this coin will fall inside this box, paper will fly off. From this we can understand the tendency of this coin to remain at rest. It doesn't want to move anywhere. Because of that, it is falling downside. Now one more example I will show you. We can take one box, or we can take a glass or a beaker with water, or we can say empty box, or I taken some coin inside. Or if you are not taking anything, then also no problem. Then we have to keep a paper on the table. On that we have to keep this box. After that we have to just a jerk, like suddenly we have to pull this paper. So you can find that the box will remain on the table. At the same time this paper will slip off. Now we can say that even if it is an empty box, then also same process you can see. But if we pull this, after keeping this box on the paper, and if we will pull this paper slowly after keeping on the table, you can find that with the paper this box also will come. But at the same time, if we are pulling the paper in a very quick way, very fast, you can find that the box will remain there, paper will come along. So this is an example of inertia at the state of rest. Now we are studying about inertia at the state of motion. The tendency of an object to move continuously with the same speed till we apply a force on it. For example, if a vehicle is moving through a plain road, example, if it is moving with the speed of 20 km per hour, we can find that till the driver apply a force, or till the driver increases the speed of the vehicle will move with the same speed through the plain road. So we can say that this is an example of inertia at the state of motion. Now we can study about inertia at the state of, or we can say directional inertia. If an object or if a vehicle is moving towards a particular direction, the object or the vehicle will move through through the same direction till we apply a force. We can say that if the vehicle is moving towards westward direction, till the driver applies a force on that vehicle, the vehicle will move through the westward direction only. So, from this topic, we can understand the tendency, or we can say the inherited property of an object to remain at the state of rest or at the state of motion, or we can say the directional inertia. Let us study pressure. What is pressure? Pressure is the force exerted on a unit area. Here let us see now. Pressure is equal to force upon area on which force exerts. So we can say that what is pressure? Pressure is the force exerted on a unit area. Now, one more way we can explain. Pressure is directly proportional to force, and pressure is inversely proportional to area. From this we can understand, if force increases, pressure increases. If force decreases, pressure decreases. Now from this we can understand, if area increases, pressure decreases. If area decreases, pressure increases. Now with the example we will study. Here, if a person moving with a high-heeled shoes, just I am showing you, the heel is like almost pointed condition. Other place, the heel is in the flat condition. Here the difference you see, heel is in the pointed condition, here heel is the flat condition. Now here very small area is there, so we can say that this heel has very less area. At the same time, this heel has area more. As a result of it, here pressure will be more. Pressure exerting on the heel of the person will be more. As a result of it, we can say that the person's heel will get pain. Here, the area of the shoes is very much big or more. As a result of it, the pressure exerting on the heel of the person will be less. As a result of it, he won't get any pain on his heel. Now, we are going to study about the pressure exerting on the water. So, for that, we are taking a bottle with water. Here, I taken one bottle. Now, in this bottle, full of air is there now. Now, inside, I am pouring water. This bottle is having full of water is there. It has no hole. Now, what I am doing? I am making hole. This line full I am making hole. So, you can find that from here, water will or jet of water will come with the same speed. Why? Because I made a hole at the same line or same plane, I can say. Now, other example. Again, I am making one more hole. I am making one more, taking one more bottle. In that again, full of water taken. Now, holes I am making at different places. We can say different heights I am making hole. You can find that this is the top part. From here, water will come down with less force. At the same time, little more downside you can find that some more distance, like that you can find. Now little more deeper area I made, so you can find that water is coming like that. So we can find that where height more, their force of the water will be less. At the same time, where deeper area is there. So here now same bottle is there, but a different height I made the holes. As a result of it, you can find that depth more, their flow of water will be with high speed. Now, one more thing I am saying you, one more bottle I taken. Again I taken full of water inside. Now here one small hole I made. Through that a tube I passed. Its one end I fixed one balloon. You can find that this is at the depth or deeper area I made the hole. So we can find that with high speed water will flow through this tube and will fill inside the balloon, and you can find that this balloon will inflate with the water. So we can say that this balloon will fill with the water. So here other places you cannot find anything, why there is no hole. Only where hole is there, through there water started to move and the balloon filled with the water. So here we can say that in all areas, in all these bottles, here water is there. This water exerts pressure on the walls of the bottle. Even we can say that it's a bottom part. Now here where hole is there, through there we can see that because of the pressure water is coming out. Other areas hole is not there, because of that water is unable to come out. Now we are studying about even air exerts pressure. For that other example we will study. Now I am taking one balloon. Now I am blowing that balloon. So you can find that that balloon will inflate. Its size will become large. So we can say that when we blow air into the balloon, we are exerting pressure. That means we can say that a kind of pressure is exerting on the walls of the balloon. The pressure which is exerting on the walls of the balloon, that is air pressure, as we are blowing air into the balloon. We can say that as and when we blow air into the balloon, we can find that it inflates. We can say that the air goes in all directions. Every direction air will go, then it will fill with the air. This balloon will fill with the air. Then we have to tie this part. We can find that here the air going and hitting at this surface, this surface, this surface, this surface. But here no hole is there. Because of that, even after exerting pressure on the walls of the balloon, it is unable to come out. But when we make a small hole on this balloon, you can find that air will go out through this hole. As a result of it, we can find that slow by slow the balloon will deflate. That means its size becomes small, again and again small, then full air will go, then it will be a small sized balloon. So we can say that here when we made a hole, so through that air came out. Similarly, we can say that through all surfaces, air wanted to come out. Why? Because air exerting pressure on all part of the balloon, but there is no hole, because of that it is unable to come out. Now we have to study about air pressure little more detail. We can say that around the earth, now I am drawing earth here. This is our earth. Around the earth, full of atmosphere is there. What is meant by atmosphere? Atmosphere means air around the earth. This air exerting pressure on all objects which are on the earth. For example, if we are standing anywhere, on our head, air exerting pressure. As a result of that pressure, it is very strong pressure acting on our head. Even on all objects, earth, air exerts pressure. Now, when air exerting pressure on our head, we are not falling. Why we are not falling? Its answer, the pressure how much exerting by the atmosphere on our head, equivalent pressure is producing by our blood. As a result of it, the pressure acting by atmosphere is balancing. Because of that, we are not falling. Now, we are going to study about other topic, that is buoyant force. Buoyant force is an upward force which is acting on the object. This buoyant force is acting by either air or water. Here we are going to study about water. For that, I am taking one container here. In that full of water I taken. On this water I kept one bottle. That is an empty bottle, but it is in the closed condition. Now, when we are pushing that object into the water, you can find that the bottle is going down. But as and when we release our hand, the bottle comes upward direction. Why it is coming upward direction? Because the water exerts an upward force on this object. As a result of it, this object came upside. The force which is acting towards opposite direction by the water, that is known as buoyant force. Now, you can find that if we are putting a small nail in this water, or we can say that a piece of iron, if you are putting in the water, they won't float, they sink in the water. Why they are sinking in the water? Its answer. Here, because of the buoyant force acting by the water. Now, why it is sinking inside? Its answer, buoyant force acting by the water is less. The buoyant force acting by the water is less. Because of that, iron nail as well as piece of iron sinks in the water. Now, here, this is a floating object. Even we can say that in the sea, ship floats. Why it is floating? Its answer, the upward force or the buoyant force acting by the water is more than the weight of the object. So we can say that because of buoyant force acting by the water is more than the weight of the object. One more thing. You can find find that some cases the objects, if we are leaving into the water, they won't sink fully, they won't float upside, but inside the water they float. Why they are floating? Because the buoyant force acting by the water is equal to the weight of the object. Now we will study what is Archimedes' principle. Here I am taking two containers. One is empty. That means only air is there. Other one is having full of water is there. Both of them are having equal height, equal size. Now I am taking one rubber band and I am just cutting it. Now its one end I am tying one stone, other end I am holding it. You can find that then I am putting inside this beaker or the container. You can find that the stone is lying in this condition. Where it is lying, that distance you have to mark and keep. Then same stone I am taking and putting inside the water. You can find that the stone is lying at this height. Why there is such a difference in the length of the rubber band as well as height of the stone? Its answer here. This water is acting buoyant force on this stone. As a result of it, the stone is feeling weightless condition. As a result of it, it is unable to come down. Here, air exerting buoyant force, but that buoyant force is very less compared to the weight or the force exerting by the stone. As a result of it, it came more depth or more distance downward direction. Now, here, why such a way the objects, or what we can say, when any object is putting inside the water, it is the water exerting upward force on this. So how much force is exerting by the buoyant force or by the water? We'll see now. If we are dipping partially or fully an object inside the water, how much water is displacing by the body? We can say that if the object is displacing more quantities of the water, so that much quantities of upward force exerting by the water. Now, if less water is displacing by the object, so less upward force is exerting by the water. If more water is displacing by the object, more upward force is exerting by the water. Upward force means a buoyant force. So here Archimedes proved that if we are keeping an object partially or fully dipped condition in the water, the object displaces how much quantities of water or how much quantities of fluid. That will be equal to the upward force exerted by the fluid or by the water. Thank you.